we will see Numpy array indexing. Numpy array indexing is similar to that of Python list. List slicing technique can be made use in indexing Numpy arrays. We will see an example. So we first create an array that is an array with 3 rows and 4 columns, which is of rank 2. So we are trying to slice first 2 rows and columns 1 and 2. So for that we can write a of colon 2. Colon 2 means the rows 0 and 1, and 1 colon 3 means the columns 1 and 2. This slicing operator works similar to that of slicing in Python list. So this will print the result as 2, 3, 6, 7. That is first 2 rows and columns 1 and 2. So modifying a sliced array will modify the original array. So B is our sliced array, which we have already seen, and if you are modifying it, B of 0, 0 equal to 77 means that the element at index 0, 1 will be changed to 77, where A is the original array. So if you run this, you can see that A of 0, 1 is 2 and B of 0, 0, which is our sliced array, and it is changed to 77. Now if you print the value of 0, 1, you can see that it is also changed to 77, because B of 0, 0 is equal to A of 0, 1. Integer indexing can be mixed with slicing. However, doing so will yield an array of lower rank than the original array. So this shows an example. We are creating an array with 3 rows and 4 columns. So this is the array we just created. So we will see how to use mix indexing and slicing. So we have A of 1, comma, then colon. So this will return the values 5, 6, 7, 8. So if you print the shape, you can see that shape is a one-dimensional array with 4 elements, 5, 6, 7 and 8. But if you are using slicing only, that is A of 1 colon 2 comma colon, you will be getting an array of size 1 comma 4. It is a rank 2 array with the size 1 row and 4 columns. So same thing will happen if you write A of in brackets 1 comma colon, which also produces a rank 2 view of the second row of the array A. But the first case, A of where we are mixing indexing with slicing, this will produce a rank 1 view. Same thing happens with accessing columns. You can mix indexing with slicing, or you can use slicing only. In that case, you will be getting array of the same shape or same rank. In that case, we will be getting array of the same rank. And if you are mixing indexing with slicing, you will be getting an array with a rank less than the original array. So this shows another way of accessing the elements. So print A of, then you will be having a to list. In the row position we have the elements 0, 1 and 2, and the column position we have the elements 0, 1 and 0, which means that the elements that should be returned are 0, 0, 1, 1 and 2, 0. The same thing can be done by writing nb.array a of 0, 0, a of 1, 1 and a of 2, 0. We can see that this will produce the same result. We can also select elements from each row using the arrange. So first we have creating an array 0 to 0. Then we are writing nb.arrange of 3. nb.arrange of 3 will return a list 0, 1, 2. And we need to return the elements a of nb.arrange of 3, comma b. b is another list, another array, Numpy array with elements 0, 2 and 0, which means that this will return the elements at indices 0, 0, 1, 2 and 2, 0. That is elements 1, 7 and 9. We can also change the values of the elements at a particular position using the same concept. So here we are trying to increment each of the values by 10. So this will give the result at the position, at the selected position as 11, 17 and 19. Boolean array indexing is also possible. We'll see an example. So first we create a Boolean index where the value of the array at position, value of the elements are greater than 3. So that will give you a Numpy array with the Boolean values either true or false. So it will return the index values as true where the value of elements are greater than 3. So you can see that first 3 elements are false and the rest of the elements are true. You can use these to index into a array, Numpy array, to select the elements. So a of Boolean index will return the values which are greater than 3. You can also get this by writing print a of a greater than 3 using the indexing concept.